Alrighty then, let's get started. This is Unit 1, Section 3, page 9 in your handout. If you don't understand what I'm saying, you can listen to the genius that wrote these worksheets, and there they are. Just scan that QR code. Okay, algebraic expressions are just a combination of constants. Notice it says expression, not an equation or an inequality. It's a combination of constants and variables using a typical operation of addition, subtraction, multiplication, division, along with a shortcut for multiplication is squares and cubes, and then the roots, which are square roots and cubed roots, etc. It's very important to evaluate an expression for the values for the variables that are contained inside them. So let's consider the algebraic expression 4x squared plus 1. Notice I said 4x squared plus 1, but we have to describe the operations occurring within this expression in the order at which they occurred. So it's not 4 times x squared, is it? Or is it? No. So the first thing you do is you square x. Then multiply by 4. Then add 1. Why am I telling you this stuff? Well, because when you want to solve, you do everything backwards. Let's evaluate this expression for the replacement value of -3. Remember, when you have positive and negative numbers, or especially negative numbers, put it in parentheses so we know that it's not 4 minus 3. It's 4 times -3 squared plus 1. Okay, now what do? Show each step in the calculation. It's 4 times 9 plus 1. Then it is 36 plus 1, which is 37. So let's see if our calculator is ever going to lie to us. Consider the more complex algebraic expression known as the rational expression or a fraction. So what I'm going to do is show you how to do this without the calculator. Let's plug 3 in everywhere there's an x. 4 times 3 plus 3 all over 3 cubed minus 7. That equals, do the top, 12 plus 3. Do the bottom, 27 minus 7. Do the top, 15. Do the bottom, 20. It says simplify. 15, 5 goes into 15 3 times. 5 goes into 20 4 times. If a student entered the following expression into the calculator, why would it give them the wrong answer? It looks the same. No, it's not, because order of operations tell you order of operations say do 3 divided by 3 before adding it to 12. There's the division there. How would we fix it? We would fix it by putting it in parentheses. Not quite there. I missed it by a hair. By putting it in parentheses. And then putting it in parentheses. Okay. Expressions can contain more complex operations such as the square root, cubed root, squaring, cubing, 10th power, 100th power, as well as the absolute values. We'll need to take a look at each one of these at different times so we can do some practice. So let's take a look at, is the absolute value of the expression? Oh, yes, those vertical bars mean absolute value. The absolute value of x minus 8, long pause, plus 2, is equivalent to the absolute value of x plus 10, long pause, because that tells you when I'm stopping the absolute value. How can you check this? Pick a number like 6, or 3. Why don't we want to pick 0? No, we're going to get the right answer if we pick 0. So pick 3. 3 minus 8 plus 2 does it equal 3 plus 10? Notice I put a 3 wherever there was an x. So we're going to check 3 right here. This is the absolute value of -5 plus 2. This is 5 plus 2 is 7. This is 3 plus 10, 13. 7 does not equal 13. 7 does not equal 13. So that didn't work. You can pick almost any number except 0, right? Oh, no. Yeah, no. 0 doesn't work. 0 doesn't work. Stay away from 0. Stay away from 1 when we're checking stuff. Let's take a look. 5 minutes through. Consider the algebraic expression square root of 25 minus x squared, no pause, so that's the whole thing, which contains a square root. Evaluate this expression for -3. So we do the square root of 25 minus, in parentheses, -3, close parentheses, squared. That's the square root of 25 minus 9, which is the square root of 16, which is 4. Why can you not evaluate the expression for positive 13? Well, I don't know. Let's find out. Square root of 25 minus 13 squared is the square root of 25 minus 169. Now it looks like the square root of -144. Is that -12? No, it's not equal to -12, because remember, the opposite of square rooting is squaring, because -12 inside parentheses, outside parentheses is the square. Does it actually equals, okay, I'm going to say equals 144, not -144. There's no number times itself that's a negative number. Okay, no number times itself that's a negative number. That's why it doesn't work. Max thinks the square root of the operation distributes over subtraction. In other words, he believes the following equation is an identity. Okay, in other words, can you do the square root of 25 minus the square root of x squared? And the answer is no. Okay, show this is not an identity. Give me a number for x. I don't care, any number. No, remember, we don't want to use 0. Don't want to use 0. Okay, so not any number. Why don't we use an easy number, 9, 3. We're going to use 3. Why I was thinking 9, you'll see why. Minus 3 squared does not equal 5 minus 3. This is the square root of 25 minus 9. See, that's where a 9 was stuck in my head. Does not equal 2. Okay, the square root of 16 does not equal 2, because 4 does not equal 2. Okay? No, does not work. We just showed it. Algebraic expression can become quite complicated, but if you don't consider the order of operations, okay, but if you do consider the order of operations from inside out, you can evaluate the expressions easily. Consider this a rather complicated one. What operation comes last in this thing? The outside. The outside. Which one's the outside? The square root. Evaluate the expression for x equals 2. Simplify it completely. Okay, so I'm going to do 2 minus 8. And then I'm going to do 5 times 2 squared plus 4. And then I'm going to take the square root. 2 minus 8 is -6. And then let me see. 2 squared is 4 times 5. Hope you're listening. Is 20 plus 4 is 24. Then take the square root. 6 over 24. And then take the square root. 1 over 4. Oh, guess what? Little trick here. You can take the square root of both sides. It is distributed over multiplication. Then it's 1 over 2. Okay. Which exercise of the following is the value of that when x equals 10? Just take 10 and plug it in. Square root 4 times 10 plus 9 minus 10 squared on the outside. All over 3. Take the absolute value of just the top. Inside is 49. Square root of 49 over 3 minus 10 squared is 100. Then just take the absolute value of what's on top. 7 minus 100 all over 3. Take the absolute value of just what's on top. That's 93 over 3 absolute value, which happens to be 31. The answer is there. Okay, that concludes your homework for today. Classwork is going to be the next couple pages. If you have any questions, make sure you ask me. I'll see you later.